radiation is coming to the earth, so there are some hindrance, or there are some when it crosses through the atmosphere, there are the lots of the particles and lots of the things which absorbs it, and then some reflects, some absorbs, some diffuses, and then ultimately it reaches to the ground. Okay, see, these data are important for the in physical science GRF examinations. Agrometeorology course is also there, so in meteorology point of view, these are important, all the data. When 100% of insolation is there, if so, out of 100, 31% of radiations directly get reflected, and that is also known as the albedo. So out of 31, you will see clouds reflect 19%, and 3% are scattered by the dust or atmospheric particles, and 9% are reflected by the ground. So now out of 100, 31s are albedo value, and now left 69. So out of total 69, total absorption is 69, but it is not absorbed, but this is not the value which is absorbed by the soil. Soil or the ground absorbs only 48%. Okay, others are absorbed by the atmosphere, like oxygen, like the 17% are absorbed by the oxygen, ozone. Okay, different water vapor and different types of the particles which are present in atmosphere, and 3% are absorbed by the clouds. You see, in stratosphere, ozone layer is there, and you have studied, maybe you have studied the formation reaction of ozone, how it is formed. You will see there is the ultraviolet is used. So oxygen is get break down into nascent oxygen and O2 molecules, and then again it get combined and it forms the O3 molecules or the ozone molecules. So ultraviolet is get absorbed in the for the formation of the ozone layer. Okay, so now, okay, these are cleared point now. See, the solar radiation is incoming. Okay, as the this is now the different form of the reflectance. So as the solar radiation is coming, so it comes as a direct beam. Okay, and when it comes to the as the direct beam, and then it's get reflected by the clouds or the reflection, and there is the term diffuse scattering. There is a difference between the reflection and the diffuse scattering. You see, reflection occurs, you have studied in class 9th or 10th or basic law of reflection, that the at the whatever angle it is incident in the reflection occurs at the same angle but in the opposite direction. So that is the reflection, or that is also called the specular reflection term. But while diffuse scattering, what happens in diffuse reflection or the diffuse scattering? Here the reflected light, reflection of the radiations occur in all the direction, in every direction uniformly. So that is called as the diffuse scattering, and diffuse scattering occurs due to the clouds. Okay. Here is different forms of the radiations. You will see the thermal radiation, heat, soil and air, and the evapotranspiration. Those are, it is the heat balance kind of that from the upper side it is coming, and from the lower side these forms are going out from the soil. And here it is the energy balance. If you will see the energy balance, now the net will be always zero. Whatever is coming, somehow it is getting used. So net will be always zero. So incoming radiations are always in the short wave. Okay, and outgoing radiations from the earth is always in the long wave. you know, we study the electromagnetic radiations. What are those? In electromagnetic radiations, there are lots of the rays, na? Like the ultraviolet, X-rays, then comes the visible range, then infrared. Okay, infrared, after that microwaves, then gamma. So do you think that in this type of the electromagnetic radiations, which are the electromagnetic radiations which comes from the sun? Can you tell me? Anyone? My question is, electromagnetic radiations are there, which are X-ray, ultraviolet, visible, infrared, far infrared, okay, microwaves. So in this group of the electromagnetic radiations, which are those which comes from the sun? Can you tell me? Anyone? Yes.
Infrared, ma'am.
Only infrared region we get from the sun.
No, ma'am. You mentioned
UV.
all radiation comes from the sun.
What?
Infrared, gamma rays, X-rays, all radiation come from the sun.
All radiations comes from the sun, right?
Yes, ma'am.
Anyone have any other answer?
UV.
See, this is the very basic thing. Okay, very basic thing. I mean, we studied from the class 5 to 6 classes. Na? Whenever we start the topic greenhouse gases, from there we study those things, short wave radiations, longer wave radiations. Okay, but you know, this is the basic thing. That is why I'm asking you. I think more than 90%, I think 95% of people will not have this concept. Everyone thinks that all the electromagnetic radiations come from.
Ma'am, I can tell something, ma'am.
Yes, tell me.
Actually, ma'am, shortwave radiation is coming from the sun, so that in the shortwave range only visible infrared, far infrared comes, and in long wave radiation that range is coming, that is not comes from the sun, and most of the UV rays are actually absorbed by the ozone layers.
That is also the short wave radiation, ultraviolet, na?
Yes, ma'am.
That is the answer. Yes, Suman, you are right. See, the short wave range means the up to the near infrared. Okay, even near infrared bhi nahi, matlab up to visible ranges mostly comes from the sun. Okay, but when it comes to the in the atmosphere, okay, then and when it gets absorbed by the you know, some metal of the soil, like the rocks, minerals, different types of the objects. So whatever the object it absorbs, okay, then when the temperature gradient is there later on or in the night, then they emit the radiation, you know. So in return, when they emit the radiation, then that is always the longer in the longer wavelength. So from the Earth's surface, it is always the outgoing radiations are the longer wave. Infrared causes the heat, we all know. So whenever sun radiations comes to us, and when heat is produced, it means longer wavelength is getting produced. So see, this is the basic thing which we study, the greenhouse effect. That is the same thing. Greenhouse effect, what it does? Short waves can penetrate it, but the longer wavelength cannot escape. Okay. So that is the all the phenomena. Okay, this is the basic thing. So I asked, and you know, you will also study the chapter remote sensing. These are the very important point for the study of the remote sensing. On the basis of this, remote sensing is completely depend. You know, in remote sensing, what we do? We study the emittance radiation of the every object. Every object have the different type of ability to produce the wavelength. Every object have the different. For example, how we distinguish between the soil and the water in remote sensing. You have read na false color chart वगैरह and all. Have you read?
Yes, ma'am.
No, but I think anyone have the clear cut concept on this? From the remote sensing, you know, each year up to 4 to 5 questions are asked. Every year in ZRF, 4 to 5 questions are asked, and very conceptual questions are asked. Okay, later on I will discuss it in the last at the end of the class. Okay. So up to here, anyone have any doubt from all these portions? No. That's good.
Excuse me, ma'am.
Ha, yes.
Ma'am, DK asked my difference between mean annual mean summer temperature and mean winter temperature. ये 5 डिग्री दिया हुआ है. अगर इससे कम होता है तब आईसो हम यूज करते हैं प्रीफिक्स.
और मैंने क्या कहा? मैंने 6 कहा.
Yes, ma'am.
Okay, whenever is the problems of the data na, to verify always use the ISSS. Okay, ISSS, Indian Society of Soil Science. Okay, fundamental is there and the introduction book of ISSS is there. So for the data, always give preference to the ISSS. Always. That is an authentic book. Okay. So in ISSS, there is the 6 degrees Celsius temperature is written. You will see. Okay.
Okay, ma'am.
So people are cross-checking me. Okay, that's nice.
No, ma'am. No, ma'am. I'm only clearing my doubt.
Good. That's good. Okay. Revise the things. This, you know, from the when we study na lots of books, so from the different sources we find different data, so it gets na we gets confused, and जो भी याद होना चाहिए वो भी याद नहीं हो पाता है. अरे एक डेटा याद नहीं होता है, 10 डेटा कैसे याद करेंगे? इस बुक में ये है, उस बुक में वो है. So always prefer one book, that is the ISSS, for the data only. ठीक है? Okay, now the percentage of the solar radiation received on Earth, we already have discussed it now, 48%. Okay, and you will see here the albedo value of Earth is 31%. That is also asked. So out of 48% radiations, okay, the percentage of the solar radiations received on Earth, these are the different types of the solar radiations. Okay, the PAR is very important, photosynthetically active radiations, which plants use for the photosynthesis. Okay, out of those 48%, 49%, okay, that is measured as the 100%, and out of that, PAR contributes to 39.8%, NIR in 38.8%, okay, far infrared 12.4%, ultraviolet radiation 7.8%, and X-ray and gamma rays 1 to 2%. See, these other orders are very important. You know, for the radiations, there are so many laws given, like the Kirchhoff's law, okay, and Boltzmann-Stephen's law. Those all study properly, you guys, okay, for the examination point of view. Here I am discussing only the Wien's displacement law, because you have to study those in agrometeorology. So Wien's displacement law is very important. Here, from here, always question is asked in various examination. You will see Wien's displacement law states that the any object which is emitting the radiation, you know, from the sun, you see, X-rays is also getting produced from the sun. Okay, ultraviolet is also getting produced. Visible range is also produced, but they have the very different wavelength. Okay, so in those all the different wavelength range, there is one wavelength which will be emitted in maximum quantity, the maximum. So Wien's displacement law states that the maximum wavelength which is emitted by any object is inversely proportional to its temperature. This is the Wien's displacement law, where omega is what? It is the Wiens displacement constant, and its value is always, if you will convert this into micrometer, it will be 2897. Okay, 2897 micrometer Kelvin. Remember this data. And for the sun, if you will calculate the lambda maximum, you will see the omega is 2897 micrometer. Okay, and temperature for the sun, what is the temperature on the sun? Tell me, anyone? Temperature of the sun. You would have read somewhere. Okay, guess it.
6,000 degrees C.
Yes, it is 6,000 degrees Celsius. So when you will calculate it, omega is 2897 divided by 6,000. Okay. So you will get this value, 0.48 micrometer Kelvin. Okay, and for the earth, what is the temperature of the earth? The average temperature of earth.
In 15 degrees Celsius, I hope.
Or in Kelvin, it will be not 15 degrees Celsius. It is 300 Kelvin. So when you will calculate it, you will get 9.66 micrometer Kelvin. You see here, this is the lambda maximum. In sun, you will see the lambda maximum is what? In the range of the 0.48 micrometer, means in the visible range. Can you see? 400 to 700 nanometers
comes in which range? Visible range, na?
Yes,
Yes,
so,
ma'am.
yeah, that is the thing. From the sun, the maximum lambda comes in visible range. But for the earth, it is coming under the infrared region. You will see here. 9,000 something. It is infrared region. In 2018, this question was asked in JRF examination. For the sun or earth, it was asked actually. Global warming potential matching, in those time, matching questions were asked, and global warming potential and for the various greenhouse gases, those were also asked. So clear this concept and revise those things. Make proper note even from now, so that at the last moment you can revise betterly. Okay. And I will tell you guys, whenever it is about the revision, I will tell you, follow the NCERT, at least 1 or 2 chapters. For the JRF, I will tell organic chemistry. Okay, for the class 11th or the 12th, organic chemistry, basic, basic chemistry, like the Nernst equations, all those things, and hydrogen chapter, like hardness of water, which form is for the permanent hardness, temporary hardness. Even in this year, in SRF exam, this question was asked for the permanent hardness, which form is responsible, bicarbonate or the sulfate or like this. So these are very basic things.
Ma'am, these portions are in inorganic chemistry, no, ma'am?
Okay, in organic chemistry, but in organic chemistry also, I'm telling you, in organic chemistry in 2019, question was asked about the double bond, triple bond, pi, number of sigma. Those questions were asked. So these are very basic things, and name reaction was asked. So from the organic chemistry, at least you don't have to need to remember all the reactions, but just go through the name reactions, name reactions are very important. Okay, which are very famous. So go through the name reactions and some basic, like the double bond, triple bond. These are very basic things. When in inorganic portions, go through this electrochemistry and hydrogen chapter at least. You see, in morning session we discussed about the redox potential and all.
Yes,
so that is also important. Inorganic part, you can, if you don't have the concept in 11th or 12th, you have not properly read out or studied, then you have to study now, because those are all linked here. or even in the PhD, what we do, we pick a topic, or and in that we go in depth and depth. So that is why it is very necessary to clear all your concepts. So here now, overall balance in soil, you will see in diurnal or the daily, the net gain in the day, I mean net gain in day is the energy or the heat is gained in the day, means solar radiations are falling on earth, so it is increasing the temperatures. But in the night, it is in the night, what happens, the temperature temperature gradient, temperature decreases from where to where, means higher temperature to lower temperature, it always moves, na. We will
And
study
surface,
about it.
ma'am, surface layer becomes cool. That's why subsurface layer temperature
Yeah,
goes out.
that is we will discuss in mode of heat transfer later on. So environmental temperature is lower in night, and the surface soil which has the higher specific capacity, so that's why the soil has the higher temperature, so it loses. Okay, so we will discuss it later, specific capacity and all those parts. But in annual, you will see net gain in the summer. Here we are talking about the season, and diurnal we are talking about the day and night. See, factors affecting amount of solar radiation reaching soil. So we already discussed, like the clouds and the in atmosphere, there lots of the soil particles or dust or the ozone layer, oxygen, water vapor, they are all affecting the soil radiations or the solar radiations which are coming. And besides that, they from the agriculture point of view, you will see the land cover. You will see vegetation canopy, snow, mulches. These all affect the soil radiation because they absorb. If there is the vegetation or the canopy, means the larger the canopy or the shallow canopy, okay, at what range it is covering. So as much as the large canopy will be there, so it will absorb the solar radiation at the canopy, so those solar radiations cannot penetrate, and it will not reaches up to the soil surface, so it decreases it. And snow have the very high albedo value, so it completely 90% I think albedo value of snow is there, so it 90% of solar radiations reflects, so it also decreases the soil radiations up to the which is reaching up to the soil. And mulching has the also effect. We will discuss about it in later on, mulching. Now the color is affected, color affects actually albedo, so indirect relationship is there. You will see dark versus the light colored soil. In which soil do you think there will be high albedo or low albedo, dark or in the light color?
Light color.
Light color.
Albedo will be low in dark color or light color?
From light color.
Dark color. Low hoga dark color.
Getting
No,
confused?
No ma'am.
Just
Low hoga dark color में.
क्योंकि कम reflect.
Low in light color and high in dark color.
Albedo will be high in light color. Means it will reflect. You know, dark color objects get more and more radiations having absorbing capacity, so it gets easily heat. You know, as for the example black. Okay. In summer, what we do? We used to prefer the light color clothes rather than the dark color. Why? Because dark color absorbs more, but light color don't. Okay, because light color reflects more and more radiation, so albedo value is higher in light colored soil. And wet versus dry soil, albedo will be high in wet or dry?
Ma'am,
Dry.
Ma'am, dry soil. It will be low in wet soil.
Why?
Ma'am, because water have high specific heat capacity.
Yes, ma'am.
In
It will
comparison to
absorb
what?
more heat.
In dry soil, what is there?
In dry soil, there are less water. So,
Less water
mostly,
means high air.
yes, ma'am, higher.
Yes. So in comparison to air, water has the maximum heat capacity or the specific heat. But this is not about the albedo.
मैम कलर को भी रिलेट कर सकते हैं ना इससे हम?
No, this is the actually property of water. You know, water can absorb, in remote sensing, you will study the spectral window. In decadence, you will study spectral window. Anyone familiar with this? Note these points and read it properly from the book, whatever I'm telling you. Spectral window, you will see these are the properties of the elements or the objects. You know, water has the property that it absorbs more and more radiations in the region of infrared radiations. From the infrared, it absorbs all the radiations. If you will give infrared radiation to the water, it will absorb all the radiations. But in case of the plant or vegetation, it will absorb more and more visible range, not the infrared. Actually, plants or the vegetation, it reflects more and more infrared radiations. That is the difference between the vegetation and water. And on the basis of that, we distinguish through the remote sensing. This is plant and this is water body, because water body is absorbing our infrared results, but vegetation is reflecting it. In a spectral window, you study this. Okay, so wet versus dry soil means the wet soil having the higher water, so it will absorb more and more radiations than the dry soil. And next one is the vegetations versus bare soil. This is very confusing. Tell me, guess it. In which albedo will be high, vegetation or bare soil?
Ma'am, bare soil.
Vegetation, ma'am.
How? Why?
Ma'am, because leaf will reflect the heat.
So you are telling that albedo will be high in vegetation, right?
Yes, ma'am.
And ma'am, I am saying that leaf will absorb the light. And thus my answer is...
Because you are answering what you told. Why vegetation will absorb more radiations?
Bare soil is more absorbed soil radiation than vegetation.
No, actually it is not. Vegetation, you will see, vegetation absorbs more and more radiations. You will see in vegetations what we have: chlorophyll, okay, even having the water. Okay, if there is vegetation, there is the water and there is the different pigments. So it all have the capacity to absorb the radiation. But in bare soil, there is nothing which will absorb the radiations in comparison to vegetation. So bare soil will reflect more, and that is why the albedo values is high in bare soil rather than the vegetation. Okay, I think these are very interesting points. Next is the aspect of slope. South facing versus north facing. So in which facing slope will be high, will absorb more and more solar radiations?
South facing.
South facing.
How? Why? Tell me, maybe I do not know.
Yes, ma'am. In the south pole, there's most of the part is ice capped, or there is some oceanic water, so that the south facing having the more albedo as compared to north facing.
Okay, that is only the reason.
Yes, that is only the reason for the high albedo in south facing as compared to north facing.
Have you read somewhere?
That is a simple concept, man. I hope.
Maybe it may be true, but actually the main reason is what you will see the our Earth is what it is 22 point 5 degrees Celsius or 22 point what at what angle it is, it is slightly length. So what happens that in the north facing, in the northern part, you will see at the first half of sunlight comes, okay, and in the south the second half of the solar radiations comes, or the more radiations will come. So in the first half there is the moisture conditions in soil, moistures are more and more. So what happens when the solar radiations comes to the soil, you will see the higher temperature of the soil is when we in meteorology we study we take the reading of the maximum soil temperature and the low temperature. So low temperature is always measured in the morning, I think at the 7 p.m. or 7 a.m. I think. But the maximum maximum soil temperature is measured at 2 p.m. You know why? जबकि लोग बचपन से सोचते हैं कि 12 बजे सबसे कड़ा धूप होता है. Is it? Why? Why at 2 p.m. we take the reading for the highest or the maximum soil temperature? Why not at the 12?
मैम उस टाइम बिग में वो ज्यादा हिट हो जाता है ना मैम, इसलिए.
यस मैम, उसके बाद मैम वो इमिट करेगा रेडिएशन,
revolution of the earth
हीट को इमिट करेगा
inside the in revolution due to the revolution of earth, ma'am. It's due to the revolution of earth.
No,
24
actually,
hour cycle, ma'am.
Solar radiations comes higher at the 12 noon. That is true, but we are studying the soil temperature, not the environmental temperature, right? So to get the heat, okay, to the soil, when it gets heated, it takes time. Whenever it comes the solar radiations, and up to 2 p.m. it gets maximum temperature. Soil temperature is maximum. Yeah, that is true. When it emits energy, so longer wavelength will be emitted, and that is the infrared region. So the temperature will be high at 2 p.m. So that is why we take the reading at the 2 p.m. So in the south facing, second half solar radiations are more. That is the more intense and higher the temperature. So you will see the south facings are more generally having the warmer temperature, rather than the north facing. Okay. So now the mode of heat transfer. We all know.
Excuse me, ma'am.
Yes.
मैम एक्चुअली मतलब रीजन क्या हुआ? एल्बिडो रीजन हुआ हाई टेम्परेचर होने का?
नहीं, एल्बिडो नहीं है. एल्बिडो नहीं है.
एल्बिडो नहीं है, वो एब्जॉर्प्शन हुआ ना मैम?
हाँ, एब्जॉर्प्शन है. वो मतलब फर्स्ट हाफ में रेडिएशन नॉर्थ रीजन्स में ज्यादा पड़ता है, जबकि जबकि साउथ में जो है सेकेंड हाफ का धूप ज्यादा पड़ता है. फॉर एग्जाम्पल अपने कोई अपना हाउस घर में देखना, जिधर फर्स्ट हाफ का धूप आता होगा ना, वो रूम जनरली कूल होता है, ठंडा होता है. बट जिस तरफ सेकेंड हाफ का धूप पड़ता होगा, जिस भी हॉस्टल देख लो या फिर अपना घर देख लो, कहीं
yes, मैम.
दैट इज द थिंग, जहां सेकेंड हाफ का धूप पड़ेगा ना, वो ज्यादा गर्म होता है. क्योंकि देखो सुबह जो है सन रेडिएशन ज्यादा आ रहा है, सनलाइट इज मैक्सिमम. बट व्हाट हैपेंस, जब सन रेडिएशन आ रहा है तो उसको क्या करता है, वाटर मॉलिक्यूल, जो हमारा इन्वायरमेंट में क्या है, वाटर मॉलिक्यूल्स है, या हमारा सॉइल में भी वाटर मॉलिक्यूल्स है, वाटर मॉलिक्यूल्स उसको एब्जॉर्ब करेगा. तो वाटर मॉलिक्यूल्स अभी तक एब्जॉर्ब किया, लेकिन सेकेंड हाफ में क्या होता है, वाटर मॉलिक्यूल्स भी इवापोरेट हो जाता है बहुत सारा. ओके, दैट इज व्हाई द सेकेंड हाफ में ज्यादा टेम्परेचर होता है.
मतलब हम ज्यादा टेम्परेचर होने की वजह से एल्बिडो ज्यादा होगा?
नहीं, वी आर नॉट टॉकिंग अबाउट द एल्बिडो ना, इन द एस्पेक्ट ऑफ स्लोप. एल्बिडो हम लोग सिर्फ इन तीनों पॉइंट में डिस्कस किए ना, डार्क वर्सेस लाइट, वेट वर्सेस ड्राई, एंड वेजिटेशन वर्सेस बेयर सॉइल. ये तो डिफरेंट थिंग है. वी आर टॉकिंग अबाउट द स्लोप.
ओके मैम, सॉरी.
See the mode of heat transfer. There are three methods for the transfer of heat. There are three modes. One is the conduction, second was the convection, and third one is the radiation. You all know. So what is the difference between all these? Here, this is the pictorial presentation. Now you can see that when we hold the any container which is already heated, then you will see this holder also gets high temperature, na? Also get heat. So that is through the conduction. Means from solid to solid, you can see this. Okay, means particles which are transferring heat from this container to the holder. Okay, these are at the same point. Okay, this iron rod or steel or whatever it is metal. So those metallic particles are at the same point, but they conduct the heat. Means when they get the higher temperature, they transfer it to neighbor. Okay, and that neighbor then transfer heat to the another, where as the temperature gradient from the higher temperature to the lower temperature. Okay. And in convection, what happens? In convection, this the particle itself get moved to transfer the heat. You know, here holder doesn't move you to this container to you. कि हाँ हमको छुओ, मतलब you know कि हाँ I got heated. Here you see, for example, you see for the we are steaming the water. Okay, so in convection, what happens? As the water gets steamed, it gets evaporated. Means water particles which are getting heat, they itself comes to us, or you know, you can see here the hand is there. So water particle or water vapor itself is going to the hand, okay, to transfer the heat. But here in this conduction, the solid material is not moving. Any particle in this metal not moving to transfer the heat. They are at the same point, but it is transferring to neighbor and to neighbor. So that is the conduction. But in convection, particles itself move. That is the basic difference between the conduction and convection. Okay, and in radiation, means convection, you see there is the need of the medium through which it can move. But in radiation, you see heat or the solar radiation, whichever which comes to the earth, that doesn't need any medium, and it transfer the heat. For example, the solar radiations, it comes through the vacuum. It do not need any medium. But as the point of the agriculture or as the soil scientist, we see only the conduction is very important for us, not the radiation and not the convection. Okay, see what is the conduction? You all know that it transfer heat from one material from temperature through the temperature gradient from the higher temperature to lower temperature without moving of the particles. Okay, so conduction is defined, or it is formulated by the Fourier's law, which states that the heat flux by conduction is proportional to the temperature gradient. Okay, as much as the temperature gradient will be high, then the heat flux means heat per unit area per unit time will be more and more. Okay, where the K is the thermal conductivity of that substance. It is the property of that substance through which heat is being conducted. This unit is very important, you know, in this thermal conductivity, diffusivity, specific heat and heat capacity. In all these, units are very important. Units are directly asked in examinations. You know, in NET examinations, they directly ask the factual questions. You don't have to think too much. So for the NET point of view, these units are very important. Okay. In 12th or the in soil, in physics, you would have studied those things. K is the property of the objects. So you see, wood having the wood is what? Bad conductor. So it doesn't have any K value or very low value, you can say. But the metals have higher K value, means the conductivity. So that is why they can conduct the heat. Okay. See, for the conduction example, a rod is there. Okay. So one end of the rod we put in the fire. So what happens at the end which is in the fire, it gets heated. Okay. And later on, the another end of the rod, it also gets heated. So in this process, any particle of the rod moved? No, no particle moved, but transfer of heat occurs. So that is the conduction. But in convection, particles itself moves, then transfer the heat. If water will not evaporate from the surface of the pan to the environment, okay, then heat will not be transferred. So that is the convection. And as the point of the soil scientist, you will say heat flow of convection occurs due to differences in densities. Okay, densities of the fluid. It means if there will be the density difference, then only they can move from the. There will be the density gradient, so they can move, or the temperature gradient. As a result of the temperature gradient in soil profile and vaporization of water molecules from the hotter end of the partially saturated soil. You know, if there is the partially saturated soil, or if there is the some amount of the water only, means it means that is unsaturated. Okay, then those convection will occur, or the soil water vapor will move into the unsaturated soil. Obviously, in saturated soil, there will not be any convection. For the convection, we need medium. Okay, we need the free medium. So in saturated soil, there is the all the pores filled with the water, soil water. So there is no movement of any gaseous state. So that is why it is always possible in the unsaturated soil. And their condensation at the cooler end, so where it releases latent heat. You know, in our home, when we cook the rice, or when we steam the water, and we we lid the cover. Okay, so what happens? The water get vaporized, and on the lid it get again in the droplet form. Droplet form means what? It get condensed. So it firstly what happens? It get evaporated, and as soon as it gets some cold surface, okay, some lower temperature, it get condensed, or it forms the water molecules. So see, when water get vaporized, what it done? It gained the energy, it get the heat from the fire. Okay, it has the very high amount of energy. When it will comes to any surface, it will comes to in contact with the any surface, it loses its energy. It gives its energy to that surface. Okay, so it loses the energy, and that is known as the latent heat. Latent heat means what? It changes the phase. So water in vaporized state, okay, what it changed? It changed its states from the vapor to the water droplet. Okay, so it releases the latent heat. That is the thing, and through which, you know, this condensation process, that is because our cloud formation is there, the most important thing. So in cloud formation also, when the water vapors evaporates and get some cloud forming nuclei are there, you would know how does cloud forms. If water is vaporizing, do you think water is vaporizing and it forms cloud directly in environment if there is nothing?
No, ma'am.
No, it can't form cloud. See, if it can form the cloud directly vaporized water, then why not in our house when we steam the water, why it doesn't form the clouds? No, it needs a particle, it needs a surface where it gets, and that is known as the nuclei, cloud forming nuclei. That is okay. So on that place, it releases the latent heat and then it get condensed. Okay. So in the cloud part, you will study in the agrometeorology. Now there are different types of the clouds. That is also very important in various examinations. Types of the clouds are asked, and mainly the shape of the cloud and their characteristics. That nimbostatus is characteristics, like the anvil cloud is called as like that. So now the radiative transfer occurs in empty soil pores as thermal radiations. As I told you that the convection and radiation is not much important for us as the soil in the soil, and conduction is the mainly process through which the mode of heat transfer is going on. So now the next, soil heat flux. Amount of thermal energy that moves through an area of the soil in a unit time. In Fourier's law, we have already discussed it. Here you will see heat flux diagram in winter heat flux and the summer heat flux. In winter, you will see the highest temperature is in night and it is again decreasing in the day. But in summer, higher temperature is in day, and from the night it is increasing. So that you guys already know. See here, it is important, soil temperature cycles. You will see there are different depths. At different depth, what is the effect of soil temperature? Here you'll see at the surface of the 2 inches of soil, which is at the surface, there is the large variation. The minimum temperature is also low and the maximum temperature is also high in comparison to other two. At the surface soil, there is the maximum variation. It easily get heat and it easily transfer heat to environment. That is why it has the highest and the maximum or the lowest soil temperature. While as we go to the soil depth, higher and higher, lower and lower, so soil variation, these temperature variations are less. Based on this, in 2019, in JRF question was asked that what will be the highest temperature or as kind of like that at the surface of the soil, like that. That kind of the question was asked. Okay.
Ma'am, what is the answer, ma'am?
What?
Ma'am, what is its answer?
I don't have remember exactly the questions now, but that kind of based on this concept question was asked. That the maximum temperature will be in 0 to 15 centimeter or as kind of as 15 to 30 kind of that. So obviously at the surface soil there will be the maximum temperature and there will be the minimum temperature also there. So variations is maximum in soil surface. You will see for example the earth has the latitude, not different latitude. So at the tropical or at the equator you will see.
Ma'am, someone has unmuted the mic.
It is disturbing.
Correct.
Rashti Patel, kindly mute yourself. Okay, see. For example, if
મંદિર બી છે પણ અત્યારે periods
દ્રષ્ટિ પટેલ
એ તો ખબર મને એ એક દિવસ જઈશું આપણે
દ્રષ્ટિ પટેલ
No, so see, for example, if we take the earth, if we study about the earth, there is the different latitude, okay, tropical, subtropical, and then the polar region. You will see that the higher temperature is always at the equator range because the incoming solar radiation is higher in the equator range. But as it moves upward, so there will be low incoming solar radiations. So you will see that the maximum variations in temperature you will see at the equator and rather than the polar regions, because at the polar regions there is a very low amount of solar radiation is coming. So where the solar radiation is coming higher in amount, then there only it will be the higher variation, because whenever it is coming, then it will have the high temperature. But when it is not coming, or at the night, or in the night, or in the winters, in the winter, you will see then it will have the lower temperature. Okay, that's why the soil surface have the maximum variations. Or in as the earth system, you will see at the equator there is the maximum temperature variations. So here it is also, you will see that there are the different types at the different depth. Okay, so here also you will see at the uppermost layer of the soil, 5 centimeter, that has the maximum soil temperature. And you will see when the winter is there, there is the minimum temperature. So maximum variation is in surface soil. Okay. Now some thermal properties. These are very important. Okay. First one is the specific heat or heat capacity. Actually, specific heat is the same as the heat capacity, but okay. What is the heat capacity? Heat capacity is the amount of the heat required to raise the temperature, okay, by 1 degree Celsius or 1 Kelvin. Okay. But specific heat is what? A specific term. It means that at the specific, it means we talk about the mass of the soil, or the in the gram or in the kilogram. So, you know, for the specific heat, it is the amount of heat required to raise the temperature of 1 gram of substance. Okay. So this is the specific heat, and heat capacity is the same thing, but we do not specify it to gram or kilogram. Okay. So that is the heat capacity. But when we specify it to the 1 gram or to any mass of the soil, then it is the specific heat. Okay. Here also the unit is very important from the exam point of view. Okay. And you will see that the soil having the 0.2 calorie per gram of specific heat, and water have the higher 1 calorie per gram. You know, in this table you will see there are different types of this table is very important. You know, in various examinations you will see either the soil, either the order will be asked, or the direct value will be asked. So you see here the maximum specific heat is of water. Okay. Then the soil organic matter, and minimum in the soil minerals. Here you see the texture determines how quickly soil will heat up in spring, or the sandy soils contain less water and therefore heat more quickly than the clay. It is about the texture, that how specific heat and the heat capacity is affecting. So it depends on the texture. So sandy will have the higher heat capacity, will have the low heat capacity actually than the clay. It get easily heated, that is related to the thermal conductivity. But as the property of the specific heat or the heat capacity, you will see that the clay will have the higher specific heat in comparison to the sandy soil. It may be because of there are the lots of the air molecules, or the higher porosity in the clay in comparison to the sand. And air is what? It is the bad conductor. So it do not conduct the temperature properly. So that is why clay have the higher heat capacity. It takes more and more heat to get heated.
मैम एक बार फिर से बताइए ना कि क्ले की स्पेसिफिक हीट ज्यादा क्यों होती है?
Okay, ma'am, I think clay having the higher porosity, and the sandy soils have the higher thermal conductivity. Okay, so it easily transfer the heat from one place to another. So that contains low heat. So sands have the sands having the quartz in more and more amount. So quartz have the higher thermal conductivity, and it has the reflectance value. Reflectance value is more. Means the albedo value in sandy soils is higher. That is why the sandy soils have the low specific heat than the clay soil. Albedo value is also responsible for this. So now bulk density and the heat capacity, there is the relation that the dry or the compacted soil, in first half we have discussed that the compacted soil is higher in bulk density. Okay, so higher the bulk density have the higher heat capacity than the dry and non-compacted soils. And fewer micropores in compacted. So in the compaction, what happens? In the compaction, all the soil particles get compact, means in the very low volume gets more and more particles. Okay, so that is why it has the higher heat capacity. And for the wet soils, bulk density and porosity do not affect much heat capacity. This is because in the wet soils there is more and more moisture. So moisture itself have the very high heat capacity or the very high specific heat. So here we give more important to the moisture content. So that is why bulk density and porosity is there, do not affect much. Okay. So next point is thermal conductivity. So thermal conductivity is what? Ability to conduct. It is the property of the objects to ability to conduct the heat. Conduction is molecules to molecules transfer of heat. Okay, as the conduction we have already discussed. So it is affected by the moisture, texture, structure, mineralogical composition, and degree of compaction. We will discuss it later on, one by one. Okay. In exam point of view, these two lines are very important. That the thermal conductivity of soil varies in order: sand, followed by the loam, clay, and the peat. Okay. As I told you that the thermal conductivity of sand is high because it contains, it has the lower porosity and it has the quartz as the mineral. So it easily get heated. You know, thermal conductivity of quartz, water, and air, you can see it is the ratio of the 333:23:1. These values are directly asked in examination. Okay. Now, how the moisture affects the thermal conductivity? We'll see that the thermal conductivity of water is about 2 to 3 times greater than that of the soil. So these are the properties. And in saturated soil, pore spaces filled with the water rather than the air. So the water having the higher thermal conductivity than the air. So wherever this in soil there is the presence of the water, then it will have the higher thermal conductivity. Okay, so wet soil have the higher conductivity than the dry. And in the texture, thermal conductivity of air is about 100 times less than that of the soil. Air is the bad conductor. So the finer soils have more particle to particle contact and smaller pore spaces. Therefore, increased conductivity. I think there is something
contrasting point here.
Yes. This is really very important point to clear. It's very confusing.
Actually, ma'am, that's the finer particle. That means particle to particle contact is nice. So packing is nice, close packing nice. So pore space is nice. So that the conductivity in the clay soil is low as compared to sandy soil.
Actually, this line is wrong, I think. Okay.
Yes, ma'am.
This line is wrong actually. Actually, what happens? The thermal conductivity is always property of the material.
Yes, ma'am.
So we are talking about the particles, sand particles and the clay particles. We are not talking about the continuity of particles to particle or the aeration.
Yes, ma'am.
So that is this line is actually wrong. Okay, but the thing is that thermal conductivity is obviously higher in sandy soil than the clay soil. So conductivity increases as texture become increasingly fine. So this is also it is also wrong actually. These two lines. Texture determines how quickly soil will heat or cool. Obviously, if the sandy soil is there, that will quickly get heated and it quickly cool in night or in in the Rajasthan or in the desert. What happens in desert areas? In the day it quickly gets a very high temperature, and in the nights it decreases to very low temperatures because it has the low specific heat. So sandy soils contain less water, okay, lower porosity, and therefore heat more quickly than the clay. That is the thing, because presence of water affects the conductivity. Okay. Now ways to manage soil temperature. Again, it comes to the about the slope north and south facing slopes. In south facing, we already discussed that there will be the warmer temperature. Okay. So when we make the ridge and furrow, then on the basis of we need the high temperature. In the winter, we need the high soil temperature, but in summer we need the low soil temperature. So depending on that, we can make our ridge and furrow in that direction. Okay. Then mulching again, color controls albedo. So we can use the black color of polythene or the transparent. Okay, you all have read it properly in the agronomy part. And various kind of the mulching materials like the straw mulch, and this contains much amount of the air, so it do not transfer heat from the soil to the air. So it makes the soil in optimum conditions or in the optimum soil temperature. Okay, it means what? The surface soil easily get if there is the bare soil, it easily get variations is there na, high easily get maximum temperature and easily gets the minimum temperature. So when we done the mulching, so there will be a gap or there will be the hindrance. So there will not be that much amount of the variations. So it try to optimize that. So that is why mulching is important. So can be used to hold moisture and control evaporation also. You can see here there is a different types of the mulching material. And these are the polythene which we use for the solar radiation or solarization is also term. Here we are doing the mulching. Okay, in winter we can use the black, I think, to get more and more soil temperature.
Yes, ma'am.
Yes. Now some questions are, you can tell me, optimum temperature for root growth of most of the crop lies between
20 to 25 degrees
20
Celsius.
to 25.
Yes, good. I do not need to explain it, right? See, these data are very important. That's why I am discussing here. In NET examination, directly these questions will be asked from the ISSS. Okay. Optimum temperature for activities of most of the microorganisms is
From 25 to 35.
35.
Yes.
Yes. Next, the thermal diffusivity. Okay, that point is left. Okay. Thermal diffusivity is what? It is the ratio of the thermal conductivity to the heat capacity, and its unit is meter square per second. So basically, it tells the rate at which temperature diffuses. Okay, so if the thermal conductivity is high, okay, so it will thermal conductivity is high means what? It easily get heated. Okay, and then conductivity is high means it easily can transfer heat to the neighbor particle. So if the thermal conductivity is high, then the thermal diffusivity will be also high. So it is directly proportional to thermal conductivity and inversely proportional to the heat capacity or the the specific heat, because it has the capacity to absorb heat na. So if it has the higher capacity to absorb the heat, then then it will not easily release its own heat to the neighbor particles. So that is why it is inversely related. But in soil order, you will see that the same order will be followed here as the in the thermal conductivity and the thermal diffusivity, because it has the direct relationship. Okay. Clear
Now-
this? Yes.
Ma'am, thermal diffusivity and thermal retentivity both are same terms or different?
Retentive.
Opposite term. It's opposite term. Inverse of term.
Retention means what? Retention means to keep it. Like the specific heat is what? To absorb the heat. To change the 1 degree Celsius, if one has the higher specific heat and one has the lower specific heat, means to change the 1 degree Celsius, the higher specific heat means it will absorb more and more radiations, more and more temperatures, more and more heat actually. Okay. So retention is to keep that. But diffusion means what? It is easily at what rate it is diffusing, means at what is it is diffusing. So both are in contrast.
Excuse me मैम.
Yes.
मैम एक एग्जांपल इसके बारे में हम मतलब देना चाहते हैं, सही है गलत? अगर सन रेज अगर अर्थ पे ज्यादा एंगल पे पड़ता है तो उसका थर्मल डिफ्यूजिविटी ज्यादा हो.
किस पे पड़ता है?
अर्थ के सरफेस पे.
हाँ.
तो थर्मल डिफ्यूजिविटी उसका ज्यादा होगा.
किससे कंपैरिजन किससे कर रहा है? We always need a reference to see.
मैम एक कंपैरिजन टू 90 डिग्री परपेंडिकुलर, उसके कंपैरिजन में.
अच्छा, okay, you have to see for that the characteristics of the thermal diffusivity, that is it affected by the angle of incidence. Diffusivity is the property of the material, so at the surface it is not responsible at what angle it is coming radiations na. Understanding, just imagine the things. If radiations is coming, how it will affect the diffusivity?
Ma'am, diffusivity means what? Scattering?
No.
No.
Not only the scattering, na thermal diffusivity it is. It is not the rate.
It is the rate of transfer of heat from one particle to another particle.
Yes, you can say. But not through the only conduction method. Diffusivity means it is transferring the heat.
इस वक्त ट्रांसफर को कितना जल्दी वो ट्रांसफर कर रहा है, कितना तेजी से कर रहा है, कितना कर रहा है, ये है डिफ्यूजिविटी. इसका एंगल से सामान्य तौर पे कोई लेना देना नहीं.
That is why it has the direct relationship with the thermal conductivity.
Yes, ma'am.
Okay, ma'am. Thank you.
Okay, it's time now, but we can also I had prepared NDVI point.
Actually, this topic is covered, I hope. Yeah, covered in next lecture, ma'am. Skip it, ma'am.
Okay, it will be covered, na? Then okay, that's fine. So that much is okay. Thank you. If you have any queries, you can ask or you can mail me later on.
मैम एक रिमोट सेंसिंग पे आप क्लास ले सकते हैं. अच्छा
है. रिमोट सेंसिंग पे एक अलग सेपरेटेड क्लास है अपना, होगा वो. आप वेट इन शेड्यूल देयर इज वन क्लास ऑफ इट में भी मैम लेगी या कोई अदर अगर स्पीकर होंगे तो वो लेंगे. Remote sensing.
You will get the specialized person for that later on.
Okay.
Don't worry about this. Everything is covered during all these sessions. Everything in the soil science. I try to cover all these things in the session. Everything. I also discussed with the ma'am for regarding to all these things. Which topic left, which topic is not covered. So you don't worry about this. We all the topics of soil science that is in the syllabus of JRF, SRF, ARS. These are covered. So don't worry. We cover all these things. Thank you, ma'am. Thank you for your precious time and you discuss very well manner all these things like soil aeration, temperature, and many more things related with all these things, and particularly the heat transfer modes and diffusion conductivity. This is the terms that is all generally students are not understand easily. So I hope all these students are preparing for JRF who will very nicely benefited all these things. So thank you, ma'am. Thank you for your lecture.
Thank you so much, Suman.
Thank you, ma'am.
Can I end this meeting, ma'am?
Yes. Okay, anyone have to say anything?
Yes. We also get the feedback to ma'am how he teach. What is the improvement in the teaching of way of teaching?
You people can give me feedback if there is negative feedback. You can also give. that will be also beneficial na for another classes or in future.
I hope there is no feedback.
बहुत अच्छा था मैम,
Yes,
बहुत
because
अच्छा
I-
से सुन रहे हैं।
Okay, getting positive response. Anyone negative response? I want negative response. That will provide me to, you know, some to improve. To it will. So that's why I will improve myself. I will get more and more better. So that's okay. You people, all the best for your examination or in later on classes. Maybe if there will be any classes of mine, then Sumar will tell me. Okay, so you guys prepare well, and if you have any queries, this is really very nice platform you are getting. In our time, we did not have any that kind of the platform where we could study like this and we could discuss the. Yeah.
इसमें
So
मैंने ऐसा सोचा है मैम इसको।
yes,
That's
you
the
see.
reason. हमको
जो
तो
प्रॉब्लम फेस करते हैं ना, देखो that is why सुमन is providing you this platform. Means हम लोग के टाइम क्या था, कौन सा सब्जेक्ट ले, ये तक मतलब कंफ्यूजिंग था कि कौन सा सब्जेक्ट चूज किया जाए जेआरएफ के लिए. There was not any kind of the platform, but you people are getting that much of the, you know, that much of the comfortness for your preparation. So you really work hard and prepare well.
को तो कुछ डिस्कशन करने के लिए आउट ऑफ कैंपस कभी मिलते थे तो डिस्कस होता था कि ये ऐसे होगा मैम, ये ऐसे होगा। दैट्स व्हाई इनको तो इतना अपॉर्चुनिटी मिल रहा है।
टॉपिक, हाँ, जो आज हम लोग डिस्कस किए ना, दोस आर टॉपिक्स लाइक कि 2 साल में जाके हम लोगों का क्लियर हुआ है, वो भी सेल्फ मेहनत से, सब इधर उधर बहुत सारे बुक्स पढ़ने से। ऐसा नहीं सिर्फ 1 या 2 बुक पढ़ने से, बहुत सारा बुक पढ़ने से। पेडोलॉजी के लिए अलग बुक, सॉइल फिजिक्स के लिए अलग बुक, केमिस्ट्री के लिए अलग बुक, और फिर लास्ट में सारा कॉन्सेप्ट एक साथ। So this in classes ka importance you people have to understand, and so you will can get the better rank, you know. Okay, thank you Suman.
Thank you ma'am. Can I use ma'am?
Okay.
Thank you all the participants for your joining. You joined and later, and next week there is also the lectures. It is that I hope next week in Saturday also 2 lectures I will try to arrange. If I have time, I could try to arrange 2 lectures in Saturday. Yet Friday, Saturday, and Sunday there is no lecture. Saturday, Sunday there is no lecture, and our university the Saturday, Sunday is a holiday, so that we don't ask in the group ki there is no lecture, there is no link. So please keep in mind there is no lecture in Saturday and Sunday. But in next week we try to conduct 2 lectures in Saturday. Try to conduct. There is some lecturers so they didn't do not deliver your lecture in previous day. Today is also another lecture, but I requested to ma'am in very short notice, and ma'am accept these things and deliver the lecture in a first session and second session also. Thank you, ma'am.
Thank you Suman.